Hello, this video is going to go over the last few problems of this practice exam. And again, I'm doing this video from study hall, so it might be a little noisy in the background, but shouldn't be too bad. They're probably going to be pretty good. Classify the triangle by side length. Determine if the triangle is a right triangle. Graph the triangle and show your work to support your answers. Graphing it isn't even really that important here. You're going to have to do all this work anyway. But let's go ahead and do that. Here's A. B is at 6, 5 up here. And then C is at negative 5, 4 right here. And if I just connect these with segments, just kind of to get a feel for what type of triangle we have, there to there to there. Notice, it might be a right triangle. Looks like this angle could be 90 degrees. Boy, it looks like these sides could be congruent to each other. It's definitely not equilateral, but it could be isosceles. How do we know for sure? So classify the triangle by side length. Here we have to find the lengths of all three sides by using the distance formula. So let's find the length of AB first. So we're going to do the distance formula here. Negative 1 minus 1 minus 6 squared. Again, away from my board. Plus negative 1 minus 5 squared. And let's see what we get here. 1 minus 6 is negative 5 squared is 25. And negative 1 minus 5 is negative 6 squared is 36. Radical 25 plus 36 is radical 61. And that cannot be reduced. 61 is prime. So there we go. AB is radical 61. Let's find BC. Again, distance formula. 6 minus negative 5, that's going to be 6 plus 5 squared. Plus 5 minus 4 squared. Let's see, 6 plus 5 is 11, squared is 121. And 5 minus 4 is 1, squared is 1. So this is radical 122. Equal sign in there, radical 122. Which is definitely different than radical 61, right? That's not that bad. And then let's go A to C, and let's see what happens there. One minus negative 5, which is going to be 1 plus 5 squared. Plus, let's see, negative 1 minus 4 squared. And let's see what we get. 1 plus 5 is 6. Squared is 36. And negative 1 minus 4 is negative 5. Squared is 25. And notice we get the exact same thing as before, radical 61. Okay, so it looks like AB and AC are in fact congruent to each other. So by side length, we can say that this triangle is isosceles, right? Because two of the sides are congruent. If all three were radical 61, then we'd have equilateral. And if all three were different, we would have a scalene triangle. But in this case, it's definitely isosceles. Now, to find out whether if the triangle is right or not, we should do all of the slopes. If any of the slopes are opposite reciprocals, then we will have a right angle. So let's find the slope. Let's go a little full screen here. Let's find the slope from A to B. Change in Y over change in X. So slope sub AB. Y is on top, so it's negative 1 minus 5 over 1 minus 6. Let's see, negative 1 minus 5 is negative 6 on top. 1 minus 6 is negative 5, and it looks like we get a slope of 6/5 for AB. It takes a long time. There's a lot of work to do here. Let's find the slope of BC. Sub BC. See what we get. A y is on top. 5 minus 4 over 6 plus 5, right? 6 minus negative 5, which is 6 plus 5. And here we get 1/11th. 11th. Whoops. That's not what I meant to do. Let's grab this guy. So those are not opposite reciprocals, but we still have to do AC. Let's see what happens there. Slope of AC. And we're going to do y's on top, negative 1 minus 4 over the x's, 1 plus 5. And what do we get here? Negative 5 on top over 6. Oops. Over 6. Let's go ahead and insert that. And we're going to cut it and paste it back here. Oops, where did it go? Here we go. So that's slope of AC. Notice here that these two slopes are opposite reciprocals of one another. You flip 6/5 upside down and then you change the sign. And these two lines are in fact perpendicular to each other. So the triangle has to be right. Okay. There you go. It's a right isosceles triangle. 3 distances for the classification by side length, 3 slopes to figure out if the triangle is right or not. 23, write the equation of a line perpendicular to y equals 3x minus 5 and through the point negative 6, 5, in slope-intercept form. Well, let's talk about perpendicular lines. Perpendicular lines have opposite reciprocal slopes. We just saw that in the last question. The slope of this line is 3. The opposite reciprocal of 3 is negative 1/3. And so that means that our line has to take the form y equals negative 1/3 x plus b. Has to be. Okay. Now what we're going to do is to figure out what b is, we're going to take the negative 6 and we're going to plug it in for x. We're going to take the 5 and we're going to plug it in for y, and we're going to solve for b. So I'm going to take my 5 equals 1/3 times 6 plus b. Negative 1/3 times 6 is negative 2, so I get 5 equals negative 2 plus b. It should be negative 6. This should have been a negative 6. Let's correct that. This should be a negative sign right here. So this should be a positive 2. My apologies. Subtract 2 from both sides, and you get b equals 3. And so just take this line all over again. Now let's replace the b with a 3. And that will be your final answer right there. Okay. We know the slope is negative 1/3 because it's the opposite reciprocal of 3. And we know the y-intercept is 3 because when we plugged in negative 6 here and 5 here, we multiplied here to get 2, subtracted the 2, we got b equals 3, and that goes in this spot right here. Don't leave the negative 6 and the 5 in. For a line, we need x's and y's. Okay, so that's a pretty common mistake that students make. 24, assume negative 3, 3, and b is 7, 2. Find the coordinates of p along the directed line segment AB so that AP to PB is 1 to 4. Okay, so this was an issue walking around the last few days, but it's really not that bad. A is negative 3, that's A, and B is 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. Okay, now let's draw the segment here, connecting these 2 points. Now, imagine if I had to walk the whole way, I would end up at 7, 2. But I don't want to walk the whole way. I want to pick a point that breaks the segment up into a ratio of 1 to 4. Now, if I have $1 and you have $4, we have a total of $5, and I have one of them. So this is another way of saying go 1/5 of the way from A to B, starting at A, going to B. So what we do here is we figure out how far is the horizontal path and how far is the vertical path. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this length is 10. And 1, 2, 3, 4, 5. This length is 5. Okay. So if I wanted to go 100% of the way from A to B, I would walk right 10 and up 5. But I only want to go 1/5 of the way. So what I'm going to do here is I'm going to find out what these lengths need to be. I'm going to take 10 times 1/5, which gives me a length of 2. Okay. That means horizontally, I'm going to have to move right 2 units. Okay. And now vertically, I only want to go 1/5 of 5. So I'm going to take 5 times 1/5, and that's just 1. Okay. This means I'm going 2 to the right and up 1 from my starting point. Because I remember it's 1/5 of the way. So I only got to go 1/5 of 10 and 1/5 of 5. So go to my picture, go right 1, 2, go up 1, and it looks like I end up at -1, -2. Final answer. Okay. Not that bad. Draw the picture, figure out the entire lengths, do your ratio fraction work. 1 to 4 means 1/5. If I said 2 to 3, it'd be 2/5 because I have 2, you have 3, we have 5, but I have 2 of it. So figure out that fraction, multiply each of these lengths by that fraction, and then march in those directions from the starting point, from that starting point, from A to B, right 2, up 1, right 2, up 1. Okay. 25. Q is the midpoint of MP, N is the midpoint of NQ, NQ equals 15. What's the length of MP? This question sounds really complicated, but it's actually not. Just draw the picture and you'll be fine. So Q is the midpoint of MP. So here is M, here is P, and Q is going to be smack dab in the middle. Okay, so here's M, P, here's Q. It's a midpoint, right? So it's going to break this segment up into 2 congruent parts. Now, it says that N is the midpoint of MQ. So again, make another point here. This is point N. This is breaking MQ up into 2 congruent parts. It says that NQ is 15. Well, doesn't that mean that MN has to also be 15? Since N is a midpoint, which means that MQ is 30. So doesn't QP have to also be 30? Because Q is a midpoint. Well, 15 plus 15 plus 30 is 60. That is the length of MP. That is going to be your final answer there. 26, determine the slope of the line containing these points. Think of difference in the y's over difference in the x's. Slope equals 6 plus 2 over -4 plus 5. Watch those negative signs. Let's see what we get here. 6 plus 2 is 8. -4 plus 5 is 1. And so we get a slope of 8. Unchanged. Back to that question. There we go. Okay. Slope here is 8. No big deal. No need to graph it. Just do the change in the y's over the change in the x's. 27, line symmetry, rotational symmetry, or both. First one, line symmetry. I'm not seeing any line symmetry here, right? If I draw a line anywhere, it's not the same on both sides. But I do think this shape has rotational symmetry, right? If I were to take this and rotate it, okay, maybe try visualizing this here. If it works, it's not going to work. Just imagine rotating this shape, and it looks like you are going to have rotational symmetry. So this is rotational only for this first one. Now here, this looks like it has both. Notice if I draw this line in, it definitely has line symmetry. It's the same on both sides. But it also has rotational symmetry. Imagine rotating this about the center point, you would get the same look multiple times. So this would be both in this case. And this last shape, it looks like there's no rotational symmetry. No matter how you rotate this, you're gonna, until you get all the way back to the beginning, you're not gonna have the same look. But you do have line symmetry here going through these 2 points. It's symmetric about both sides of that line. So I would say line only in this case. Okay? Make sure you know rotational symmetry, line symmetry. Some shapes have both, some shapes have neither. Some shapes have only one. 28. Fill in the blank proof. We're trying to show that lines M and N are parallel. And notice here, it looks like it's pushing us towards talking about angles 2 and 3. Now, what you should be thinking here is, what kind of angles are 2 and 3? Well, it looks like they are consecutive interiors. And what do we know about consecutive interiors? Well, if those consecutive interiors are supplementary, then the lines are parallel. So my guess is here, since we're looking at 2 and 3, we're probably trying to show that 2 and 3 are supplementary angles. That's probably the goal here. So let's see what we get. Line 1, angles 1 and 3 are sup, that's given. Therefore, the angles add up to 180. Isn't that the definition of supplementary angles? Okay, we know that that happens because that's what supplementary angles do. Well, it looks like we're changing gears here. Angles 1 and 2 are congruent. Well, what kind of angles are 1 and 2? These look like verticals, and they're congruent by the VACT, the vertical angle congruence theorem. So that's going to be line 2. Now, how do I, kind of looking forward, how is this useful? Notice line 3 says definition of congruency, or maybe definition of congruent angles. Notice in lines 2 and 4, which actually should be line 5, but whatever. Notice that line 2 and line 4 are the same, except for the 1 is out and the 2 is in its place. That means I'm likely going to pull a substitution here in line 4. But I don't have the measure of 1 equals measure of 2. I have angle 1 is congruent to angle 2. So likely what we're going to do here is take a step to say measure of angle 1. Do I have an angle symbol? Doop, 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 doop. Anywhere, anywhere, anywhere. Looks like no. It's okay. I'll just do a less than sign. So I'll say measure of angle 1 equals measure of angle 2. I know those are less than signs, but it's supposed to be angle signs, but you get the idea. Okay, measure angle 1 equals measure angle 2. Now look at lines 2 and 4. Again, these are the exact same, except for the 1's out and the 2 is in. This is just a substitution. And now look at line 4 says 2 and 3 add up to 180, and then line 5 says definition of supplementary. Well, these are supplementary angles, right? But we have to say that in English. Angle 2 and angle 3 are supplementary. That's going to be line 5. And line 6, it's going to be M is parallel to N. How do we know that? Well, since 2 and 3 are supplementary, we know the lines are parallel. We call that the converse of the consecutive interior angles theorem. Okay, the CC consecutive, no S here. It's the converse of the CIAT, consecutive interior angles, and it's the converse of that, right? The original said if the lines are parallel, then consecutive interiors are supplementary. The converse says if consecutive interiors are supplementary, then the lines are parallel. So here you're using a converse to prove the lines are parallel, not the original. Okay, so feel free to go back and listen to that again, but that would be proof number 28. Here's number 29. C is the midpoint of AG. So let's go ahead and sketch that on the picture. What's going to happen here? C is the midpoint of AG. That means that CG and AC are going to be congruent. And we're also told that HG and AB are parallel. Okay, so I'm thinking maybe alternate interiors or something like that. We're trying to prove that this triangle on the left is congruent to this triangle on the right. So let's see what we have here. C is the midpoint of AG. That's true. Therefore, AC and GC are congruent. That would be the definition of a midpoint. Okay, that's what midpoints do. They break up segments into two congruent parts. And now we're going to use the vertical angles theorem. Now, we're trying to prove that this triangle and this triangle are congruent. So we might have to use vertical angles that are applicable to those triangles. And I'm thinking it's these guys right here. Okay. Now, HCA and BCG are also vertical angles, but those aren't angles of our triangles. Okay. So pick the ones that are applicable. So I'm going to say here that angle H, that's not an angle symbol, angle HCG is congruent to, we'll write out the word instead of the symbol, angle, let's see, ACB. Going a little simple there, congruent symbol here would be perfect. So we have pair of sides, that's one of the S's. Angles are congruent, that's a pair of angles. Now, what do these parallel lines have anything to do with? Any? Probably alternate interiors. HGA is congruent to BAG. Now, aren't those alternate interiors right there? This guy and this guy? Those are alternate interiors for these parallel lines. So this is going to be AIAT, line 5, and that means the triangles are congruent. Now, why are they congruent? Sides, only one pair of sides, angles, two pairs of angles. Are the sides included or are they not included? In this case, they are included. They are in between the angles that we know. Therefore, we would say that these triangles are congruent by ASA. Last one. Given a couple parallel lines, prove that JM is congruent to LK. This is probably going to be one of those CPCTC deals where we have to prove the triangles are congruent and then use CPCTC after. It looks like MK is congruent to itself. That's probably a good place to start. So let's say MK is congruent. Here's that congruent symbol. There we go. It's congruent to MK. And then, of course, I should have segment marks over that because we're talking about shapes. But again, away from my board, so just kind of deal with the ugliness. And that's going to be the reflexive property. You know that well. Now let's do these two givens. JK is parallel to ML. Given. And now how does that help us? Well, if JK and ML are parallel, doesn't that mean that angle JKM is congruent to LMK? Those are alternate interiors. So let's write that down. That means that angle JKM congruent angle LMK. And that's by the AIAT. Now let's do the other pair of parallel lines. MJ parallel to KL. Segment on top. Up here too. Segment, 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 segment. And that's given. Now the same thing happens here, but for the different lines. Now these two lines are parallel, and now these are my alternate interiors, right? It depends on which angle, which lines are parallel as to which alternate interiors are congruent. So here is JMK, angle JMK, congruent to angle LKM. AIAT. Right there. And so these triangles are congruent by, it looks like, again, angle, side, angle. So let's write that out. I have a triangle. Let's do that in math here. Where's that delta symbol? There it is. So it's triangle. Let's call it KMJ is congruent to triangle. Well, if it's KMJ, then I think it has to be MKL. Sure, you can do that. Find out the congruence statements, and that's going to be by ASA. Now that means that JM is congruent to LK. Line segments on top. And that is by our best buddy in the world, CPCTC. Okay. So if you can do all these 30 questions, you're probably in really, really good shape for the exam. Feel free to watch the video as many times as you need to. I will go over problems for 8th period. It'll be today on Tuesday because your exam is Wednesday. And then for 1st and 7th period, I'll go over questions on the board, anything you might have on Wednesday just to help you out. So good luck. Do your best. Let me know how I can help you.